Digital transformation in smart factory is a very exciting and yet challenging topic. So before we talk about security for OT and IoT in smart factory, let's talk a little bit briefly about what is digital transformation in smart factory. A simple way to think about this is we connect all the equipment, the controllers, the sensors in the factory, and from there we collect all the data, and then we classify them, categorize them according to their kind. We analyze them. Okay. From there, we get the useful information out of it. And from there, the information can be presented and used by the operation and business managers and executives. So this is an enterprise war room from one of our clients. Through a successful digital transformation in their smart factory, they are able to put all the information in one panel. This includes the ERPs, the MES, the factory floor, facility information, the production status, and even the predictive maintenance for when is the next time to do the maintenance thing, and energy consumptions, and so on. So with a successful digital transformation, this executive enjoys a successful outcome from the digital transformation in the factory. They are able to achieve substantial electricity cost down, and their productivity was up. And she has a real-time view of the gross profit, and she knows exactly what's the equipment uptime status, and also when to do the maintenance. So she can do all those things which she couldn't do before. Now, little did she know, while she enjoys these benefits from the successful digital transformation, there are, however, cybersecurity risks associated with it. First, the OT and IoT devices are now connected to the network. Those were not there in the past. And those devices, they are extremely diverse, and they are dedicated equipments and devices used for specific process purposes. Those devices tend to be very dedicated and specific. Therefore, they don't have sufficient hardware resources. By that, I mean like CPU horsepower or memory storage capacities. So therefore, it's not possible to incorporate security software agents in those devices. So here are some examples, like this one in PM 2.5 particle counter, or here is an IR reflow equipment, or an old grinder, and so on. Those devices, even with embedded PC, they may have been out there for ages, and they are running outdated operating systems like Windows 7s and Windows XPs, and not been patched up to date. So those definitely will introduce cybersecurity vulnerability. And for that, IBM had a report recently. They talk about threat actors. They're actually particularly interesting in organizations with OT networks because of the costly downtime and the impact on the wider ecosystem, namely the supply chain, the customers. If the factory is down, the impact to the downstream customers can be very significant. So with all that in mind, we approach the customers. This is a real customer. We approach the customers. We promote to them about the OT security solution. And for those of you who are in this business, I'm sure you'll find that very challenging. There are also the reasons why this is still a very hard sell. For example, this customer has a false sense of security because they believe all the OT, IoT devices were not connected to the network. And now they don't talk to the outside internet, so there shouldn't be any problem. And they even believe those are isolated from the internet. even in most cases, they are really not. And another thing is the cost, obviously, because factory people are very good at calculating the cost associated with their production. So adding all the security to the factory is a cost adder. Even if something were to happen, this can save them a lot, but this normally is hard to be incorporated into the ROI calculation. Another very important factor and concern and barrier is actually the lack of security personnel. Most of the OT environment, they simply don't have the right people to work on this. So it's very convenient for the factory executive to turn down adopting the OT security solution. Nevertheless, we continue to pursue these customers. So finally, customers agreed to do a demo with us. Okay, so the way we approach the demo is we started with surveying the environment, and then we identify a mobile sensor. So we attack the sensor. And what we showed them was, in order not to interrupt their factory, by the way, so we did a simple hacking example. We changed the calendar year on their sensor. And as you can see here, it says 2025, which obviously is not the current year, right? So that gave them an idea about how easy an OT environment can be hacked, once hacker has the access to the environment. Now, some of you may be wondering, so what is the big deal about a sensor, right? I mean, sensor seems like it's so harmless. Well, let's take an extreme example. For those of you who have heard about Stuxnet, Stuxnet, by the way, is an Iranian nuclear facility. In this particular attack, Stuxnet was able to modify the controller codes and commands, while on one hand, it returns the normal value to the users. So users think everything is fine, it's normal. But in reality, the controller has been hacked, and the fast-spinning centrifuge is going in such a way that it actually tears itself apart. And in this particular example, it caused a significant percentage of the nuclear uranium enrichment facility in Iran. So with that demo, customers agree on to proceed with a POC in their factory. So in this particular POC, what we did was we focused on monitoring, protecting the Purdue level 0 and 1 devices. And from this schematic diagram, one can see the factory IoT devices and equipments, they are protected by an intelligent security device, which is eSafe's security device. And the IoT devices are protected either as a group or individually. And by learning the IoT device network communication pattern and establish a baseline, we are able to use that baseline to detect the anomaly for those devices in the event that there are hacking, breaching going on. We are able to see the difference between the normal baseline behavior and a abnormal behavior. And by virtue of the close association of those security devices to the IoT level 0 and level 1 devices, we're able to provide a clear visibility of those devices so that factory personnel knows exactly what's going on with them. And also, we're able to provide environment for micro-segregation, meaning any infected devices below or above can be prevented to avoid further spreading upwards or downwards or horizontally. And of course, the system is able to provide the event logs and send log the event data to the platform manager. to do further analysis to correlate those events to cyber threat intelligence. And whatever the information or the alert can be presented in the dashboard. So that's the POC features and the focus we did with the customer. And as we proceed with the POC, one day we find out there are DNS traffic attempting to connect to malicious domain. And we look at those domain names, and then we find out those are actually WannaCry ransomware. And further investigation, we actually find out the malware was hidden in 3 machines for more than 77 days. And with that results, obviously, the customers was surprised, and they were not happy to see things like this happening. Nevertheless, that changed the perceptions for the factory management. And with that, they agreed to proceed with a full deployment to protect their smart factory. Here, what we see is a 3D factory floor map. And we also see lots of red dots deployed to the plane. Those red dots, they are the security devices that we deployed. They are arranged in a cellular-like type of network architecture to provide the deep visibility in the environment for microsegregation, as we just talked about. And the arrangement is such that it's able to protect the full factory. And the results obviously are presented in the dashboard. So this is one of the factories that we deploy to this client. Now, as most of us in the security business know, security actually is not an easy and it's not a 100% thing. As we proceed further with the customers, we actually realize the factory and office area, they are co-located. The office PCs and all the equipments, they are connected to the same network. This is not a very good thing. Nevertheless, customer did that not because of the negligence. This was done because of the necessity, because business managers, the operation managers, they will have the need to access the information real time so that they can make business decisions in real time. So with that in mind, we proceed with the customers to integrate all the security into customers' IT security platform, which is a SIEM, Security Information and Event Management System. In this case, customers use IBM's QRadar for this purpose. So what you are looking at here is a dashboard presentation from QRadar. It integrates information from IT side, the UTMs, the controllers, network access controllers, and of course the OT security solutions as well. And this was done across different sites, includes 2 factories and the company headquarters in different geographical locations. And this gives customers a full visibility of their enterprise security. With that, that summarizes the examples and the takeaways I'd like to provide to you. First, the digital transformation benefits, although provides lots of those goodies, it does come with security risk, as we just talked about. And the OT and IoT devices, they are with inherent vulnerabilities. So those will need to be protected with dedicated solutions. There are several dedicated OT security solution providers out there. You can choose your favorite vendors to work with to help you to solve your OT security needs. And lastly, it's quite helpful and valuable to have the OT security integrated into the enterprise IT security environment so that company can have the full security visibility. Thank you.